Okay.
Yeah, and I'm studying the science stream, like the maths, computer.
Okay, the science
computer.
stream you've
Yeah.
chosen. Okay.
Yeah.
Okay, so apart from, okay, on a scale of 1 to, let's say 5, I'll not make it 10, on a scale of 1 to 5, how would you rate yourself? I will not say aptitude, in terms of your liking for maths. Like, how would you rate yourself? Where do you think you would stand on a scale of 1 to 5? Or
3.
means you don't like it, or
Like
or
in
it's like
between, like
you're okay with it? Which is your favorite
yeah.
subject?
Favorite? Yeah, computer.
Computer science.
Yeah.
Okay, into software. Okay. All right.
Yeah.
Okay, so this is about, so welcome to the demo class for today.
Yeah.
So the topic is binomial theorem. All right, I'll just share my screen, and just help me to understand few things before we start the class.
Yeah.
See, basically, I want to know whether this topic has been taught, or it's like new to you, or what is it?
It's new to me.
It's totally new to you.
Yeah.
Okay, fine. And I can take it from there, because if you already know something, I can take it from there. That's right. All right, Aishwarya. So let me start off with the sharing the screen. Okay. I'm just see if my whiteboard is visible to you. Okay. You can see my whiteboard?
Yeah, I can see.
Okay, great, Aishwarya. All right. Let us, the topic for today is binomial theorem. Okay. So what exactly is this binomial theorem? So in earlier grades, like maybe even before 9th and 8th, maybe you would have come across a plus b the whole square, which is a square plus 2ab plus b square, isn't it?
Yeah. Yeah.
This is a binomial, isn't it? An expression containing two unlike terms is a binomial. A and b can be anything. Yeah, they can be two unlike terms, of course. Yeah, maybe one of them can be a constant. Both of them can't be constants. In that case, we would merge them, right? But preferably one of them would be a variable, the other would be a constant, or both of them can be variables, so on. So then, you know, a plus a minus b also, isn't it? That's the same thing. This is pretty much familiar to you, known to you. And a plus b the whole cube is a cube plus b cube plus 3a square b plus 3ab square. I mean, the way you have learned might be different in terms of the order, isn't it? Might be, well, whatever. So likewise, we have a minus b the whole cube. So what am I doing basically here? What is this a plus b, a minus b, and it's a binomial. I'm expanding the binomial. Yeah, I'm raising the binomial to different powers. These are all something which I know, it is kind of familiar to me. Yes, these are all, this is like a minus b the whole cube, a plus b the whole cube. I've already learned it in my lower grades. Yeah, so nothing big about it. But here, when it comes to higher powers, let us say I give you Aishwarya and I say, come on, calculate the value of a plus b to the power of 10. Then it's going to be difficult, isn't it? Then you can't just see, you're familiar up to this level, possibly, right?
Yeah.
Do you know a plus b to the power of 4?
No.
No. Okay, that's fine. And the reason I asked is, so maximum, you know, Abdul, expanding a binomial, expanding it. Yeah, you're raising it to different powers. So if I ask you even 8, why do you have to go to 10? Even if I ask you 7 or 6, it's going to be really difficult for you, isn't it? So that's why we have a theorem. It's called as a binomial theorem. And this theorem is going to help us in computation of a binomial raised to different powers. See, we have a plus b raised to power 7, and we can have a plus b raised to power 8, and so on. Okay. So we are raising this binomial to different powers. Okay. So how does this help me? This theorem is going to help me to compute the values in a very easy manner. All right. In the sense, see, you might tell I have calculators. We have so many things. If I give you, for example, 99 to the power 2. So the best thing I can do is 100 minus 1 to the power 2. And we use that a minus b the whole square, isn't it? This is one approach. Or if I give you, let's say 101 the whole square, I rewrite it as a binomial. Yeah, I mean two entities rather. I won't say terms. I would write 100 as 100 plus 1. So I know that a plus b the whole square will be used here, isn't it? This is familiar to you, right?
Yeah.
The thing is, when I'm coming to like 101 to the power 5. How do I expand it? Can I keep on, writing 101 into 101 and doing multiplication? So without even the help of a calculator, if I'm going to solve it, I can solve it. I can go and do my work, but easily I can do it using the binomial theorem. Okay. So this is what it is. To understand further, let me take you to something called a concept called as the Pascal's triangle. Yeah. So Pascal's triangle. Now, if you see in the history of mathematics, I would say development happened at different parts of the world. Sometime back, hundreds of thousands of years, 200 years back, we didn't have the mobility that we have today, right? We have Newton, we have Leibniz, we have Pascal, and we had Einstein, our very own Einstein. Then we had Ramanujan, Srinivas Ramanujan, Aryabhatta. There were so many mathematicians history has seen, yeah, and they kept working on different things. So mathematics, development of maths as a subject happened simultaneously in different parts of the world, right? So it was not like so. Maybe suppose there's a mathematician in India who found something. The same time, somebody else found something similar in some other part of the world. But since we did not have the mobility that we have today, so things were, the credit was given to somebody else. That somebody else has already found it. You understand? See, Pascal's triangle. This is also called as Meru Prastara by in India by an Indian mathematician called Pingala. Okay, so this is just for your reference. So it is called as Pascal's triangle, but it is also found by another mathematician, but then the credit goes to Pascal. So what is this Pascal's triangle all about? See, I'm going to arrange some numbers and you'll understand this. 1, 1, 1, 1, 2, 1. I will not say anything. I'm just going to keep on writing some terms, and then you will get to know what I'm trying to talk about. 3 plus 1, 4. So you see, in the first place, now I'm going to also write the coefficients. A plus b power 0, a plus b power 1, a plus b power 2, a plus b power 3, a plus b power 4. Does it ring a bell somewhere to what I have written and what I'm talking about with respect to this binomials? Can you relate something to this? What is a plus b the whole square? A square plus 2ab plus b square. What is a plus b the whole cube? A cube plus 3a square b plus 3ab square plus b cube. Isn't it?
Yeah.
Can you relate something to this? 1, 3, 3, 1, 1, 3, and then 1, 2, 1 for square, and likewise. Yeah?
Yeah.
Okay. If you do a plus b power 4, it will be a power 4 plus 4 times a cube b plus 6 times a square b square. How did I write it so easily? I'll tell you now with respect to this triangle. Plus 4 a b cube plus b power 4. Yeah. Okay. So if you see in my expansion, the coefficients correspond to the entries in the Pascal triangle. Did you realize that?
Yeah.
And how did I get these entries? You start off with 1. This corresponds to the row a plus b power 0. And we know that anything raised to the power 0 is 1.
1.
Yes? This is a plus b, second row a plus b power 1. So the coefficient a plus b power 1 is 1 minute. I'll just make space. Yeah, a plus b power 1 is a plus b. Coefficient of a is 1, coefficient of b is 1. Got it?
Yeah.
So that 1 and 1 come from here, right? Next is a plus b power 2. A plus b power 2 will be a square plus 2ab plus b square. The coefficients will be 1, 1, 2, and 1. Got it?
Yeah.
And now you see, how did I get this? 1 plus 1 is 2. Yeah?
Yeah.
1 plus 2 is 3. Just follow the pointer. My torch. 2 plus 1 is 3. Yeah? See this, you have a sequence of 1 which progress like this, likewise this way. 1 plus 2 is 3. 1 plus 2 is 3. Here 1 plus 3 is 4. 3 plus 3 is 6. 3 plus, so this corresponds to a plus b the whole cube. Can you see? I'll just show you. That's a cube plus 3a square b plus 3ab square plus b cube, isn't it? You forget this, you just look at the coefficients. 3, 1, 3, 1, 1, 3, 3, 1, isn't it, in the expansion? And notice something. Here it is a power 3, b power 0, okay? And here it is a power 2, b power 1. A power 1, b power 2. B power 3, a power 0. Anything raised to power 0 is 1, isn't it? So what do you observe here? At in any, there are how many terms? 1, 2, 3, 4. In a plus b the whole cube, there are 4 terms. So what is a plus b cube means? 3, right? Index is 3. 3, for that 3 you add 1, you will get 4. That many terms. Got it? Okay. A plus b the whole square. The index is 2. Power is 2. How many terms? 2 plus 1, which is 3. Isn't it? A plus b the whole square. A square plus 2ab. I mean, just stop me if you think it's, because this is something relatable. This is something that you know from algebra. So are you able to kind of get a grasp of the Pascal's triangle?
Yeah.
What I'm trying to say is in a plus b to the power n, in a plus b to the power of n, I will have n plus 1 terms. Okay, we'll look into that later. Coming back to the Pascal's triangle, again you see 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4. This entire row corresponds to coefficients in the expansion of a plus b to the power of 4.
Okay.
Got it? And that's how I developed this. Can you see? Can you see? Follow my thought, see? Because a power 4 plus, so what is happening? So you have the highest power of a here, a power 4. I'll just show you, wait one minute. See? So you have a plus b to power 4. Now you can tell me, you can write it as a plus b square, again square, isn't it? That is also, it's like a square plus b square plus 2ab, that's being squared. Or I mean, if you look at it this way, you're squaring this. Yeah, this is another way of doing it. That is a plus b to the power of 4. So, but instead of expanding this directly, I have a formula. Yeah, that is a plus b to the power of 4. In the, if you look at the Pascal's triangle, 1, 2, 2, 1, I'll just develop it quickly. 1, 4, 6, 6. 4, 3 plus 1, 4, 1. See? So I got the Pascal's triangle. So in this, I can write the coefficients. Yeah. So, so 1, a power 4. The highest power is 4. Okay. You can't go beyond that, obviously. And b will be 0 power. It wouldn't matter if you don't put 0 also, it's okay. I can just write this. Plus, next coefficient is 4. Power of a has decreased. Power of a from b power 0, it has increased to b power 1. Got it? The powers of a keep on decreasing. Next is 6, right? 6. Now powers of a is decreased. From 3 it becomes 2. B from 1 it becomes 2. They both are even now. Got it? Yeah. Now I'll continue this. Plus 4. Now power of a from 2 it is decreased. Power of b from 2 it has increased to 3. Then the last is 1. Power of a is become 0. Power of b has become 4. And we stop. Because the maximum that power that a or b can achieve or attain is 4. Isn't it?
Okay.
See now, what is the index here? 4. 4 is the index and the expansion of a plus b to the power of 4. And 4 plus 1 is 5. So there are 5 terms, isn't it? 1, 2, 3, 4, 5. 5 terms will be in the expansion. Yeah. So I don't have to, okay, this is still simple, I'm saying. You might always say, yes, why don't I calculate? Think of larger numbers, a plus b power 6 and all. That's when it becomes easy for us to understand. So yeah, this is about it. So one more thing that you need to observe is, at any given time, look at the terms. There are 5 terms. You observe, you add the powers of a and b. A and b are the components of the binomial, isn't it? we're applying binomial theorem here. Before this, so when you add 4 and 0, the power is 4. 3 plus 1, 4. 2 plus 2, 4. 1 plus 3, 4. 0 plus 4. So at any given time, the sum of the powers will be 4, will be equal to 4. Yeah.
Yeah.
So if I have a plus b to the power of n, now where n is any, okay, let me specify. N can be any integer, or it can be any positive number, or any negative number, or it can be any rational number also. Yeah.
Okay.
Like 2 by 3, 3 by 2, 1 by 4, so on. But as far as the scope of CBSE grade 11 is concerned, NCERT grade 11 is concerned, we would restrict ourselves to n being a positive integer. Okay. We will not go, we are not going beyond this for now. So we'll only talk about n as a positive integer. So now how to expand this? So the expansion of, now let's see carefully, it is NC0 a to the power of n minus r b to the power of r, right? This is a general expansion. So what we do is NC0 a to the power of n, n, then b to the power of 0, isn't it? I have not yet come to b as yet here. Next, NC1 a to the power of n minus 1. The powers of a keep on decreasing, b power 1, plus NC2 a to the power of n minus 2 e to the power of 2. So how long can I go? How far can I go rather? NCN a to the power of n minus n, isn't it?
Okay.
I finally, then b becomes n, as in a becomes 0. In other words, power of a should become 0 and the power of b will become n. Up till there I can go on. And there'll be how many terms? N plus 1 terms. Because the index is n, isn't it? Okay, fair enough. But what is this NC0? What is this NC1? Isn't it? So I think you have learned permutations, combinations, right? You have a knowledge of, there you would have come across this, right? NC0, n factorial by r factorial into n minus r factorial. That is that NC0.
Okay.
Yeah, the binomial coefficients in the expansion. Yeah.
Yeah. Okay.
I'll just take a very simple. So what is NC0? NCR rather. NCR, I'm saying, sorry. NCR. So NC0 will be n factorial. In the place of r, you have 0, isn't it? R, got it? R, in the place of r, you have 0. In the place of r, there is 0. So n 0 factorial by n minus 0 factorial. Okay, since you know something about binomial theorem, I mean permutations and combinations, Aishwarya, can you tell me what do you mean by 0 factorial? What is 0 factorial? Huh?
1. Is it 1?
Very good. Very good. Very good. What is 1 factorial?
1.
Very good. What is 2 factorial?
1 into 2.
2 into 1. Yeah, 1 into 2. Or multiplication is commutative. 2 into 1, which is 2. Great. What is 3 factorial?
3 into 2 into 1.
Exactly. Which is 6. So and so on. So by the definition of NC0 becomes what? N factorial by 0 factorial is 1. N minus 0 is n factorial, which is 1. So NC0 is 1. N is 1. That calls for why you have 1 here and you have 1 here, isn't it? The last two values, you got it? In the Pascal's triangle, see, you have a sequence of 1, isn't it? The bounds are 1, right? Yeah, that is what you need to understand. Yeah, so NC0, because you start with NC0, a power n, b power 0, blah, 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 and then you go on to NCN, a power 0, b power n, isn't it? So NCN and NC0, they both will be 1. Up to this part is clear with you, right? NCR. And you also know there's one more formula. NCR is equal to NCN minus R, isn't it?
Yeah.
So you will we'll incorporate all this in our when we define binomial theorem. I mean, when we use the binomial theorem. So a plus b to the power of, let's say, 3. let's say I do not know anything. I'm going to apply binomial theorem. So, okay. So what is the formula for a plus b to the power of n? It will be nc0 a to the power of n b to the power of 0, isn't it? Plus nc1 a to the power of n minus 1 b to the power of 1c plus nc2 a to the power of n minus 2 b2, and we go on all the way up to the when a becomes power of a becomes 0, power of b attained is n, and of course there will be n plus 1 terms. So when we employ the same thing here, my n is what? What is my n? It is 3, isn't it? N is 3. Great.
3.
So n is 3. So next what? When n is 3, I'll apply in the place of n, I'll put 3c0 a to the power of 3. You're able to map it, right? A power 3, b power 0 plus 3c1 a power 3 decreases to 2, right? You keep on decreasing a powers of a, keep on increasing powers of b, plus 3c2, 3c1 a power 2. So now what happens? It becomes a b power 2 plus 3c3. Yeah, ncn we reached, isn't it? A power 0, b power 3. So when the power of b becomes n, in this case 3, and the power of a becomes 0, we stop. So this is what it is. There are 4 terms, isn't it?
Yeah.
3c0 is, what is it? 4. It is 1. Yeah. So nc0, 3c0 is 1. A cube, and b power 0 is 1 plus 3c1 is 3 itself. A square b plus 3c2 will be what? Yeah. 3c2, we just calculate 3 factorial by 2 factorial. I know it, but just I'm letting you know how it is got here. 3 minus 2 factorial, which is 1 factorial. 3 factorial can be written as 3 into 2 factorial by 2 factorial. Okay. So that is again 3c2 is 3 into ab square. 3c3, I didn't see n will always be equal to 1. So it is a power 0 is 1 into b cube. That's how we got a expansion of a plus b the whole cube. So you can apply this, you can expand this logic to anything like a plus b the whole power 4, power 5, and so on. Yes. Where do I start off with? A plus b power n is nc0 a to the power n b power 0, isn't it?
Yeah.
Yeah. Now, if I'm going to compare it with, my r, it is ncr a to the power n minus r b to the power r, where in the first case r is 0, isn't it?
Yeah.
Now listen carefully. nc1 a power n minus 1, because powers of a keep on decreasing, right? Now this is ncr a to the power of n minus r b to the power of r, isn't it? Here r is 1. Yeah, this is my first term, this is my first term, this is my second term. Yeah. So the r plus 1th term, tr, in arithmetic progression you would have come across t and t, isn't it? The r plus 1th term, tr plus 1th term will be ncr a to the power of n minus r b to the power of r. Means if I want first term, I have to put r is 0. 0 plus 1 is 1, isn't it?
Yeah.
If I want second term, I must put r is 1, because 1 plus 1 is 2. Getting it? For the first term, you get nc0. Second term, it is nc1. Got it? So for the let's say I want the 5th term. That means tr plus 1. My r plus 1 is 5. As in r should be 4, isn't it? The 5th term will be nc4 a to the power of n minus 4 b to the power of 4.
Okay.
Did you get this?
Yeah.
So the r plus 1th term is ncr a to the power of, this is what it is. So far, so what now? You might relate back to, see, I spoke about a lot of new things today. I also spoke about Pascal's triangle. Yeah. So coming to Pascal's triangle, we have 1, 1, 1, 2, 1 and all. So you might tell, okay, I can go on use, you can use the Pascal's triangle. Yes, you can use Pascal's triangle to what extent? Can you keep on developing those values? 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5. You know, you got it how I got this? 4 plus 1, 4 plus 6,
Yeah.
plus 4, isn't it? So this will correspond to what? This is cube, isn't it? This is cube. N is equal to 3. This is n is equal to 4. This is n is equal to 5.
Okay.
Did you get it?
Yeah.
Huh. And you can keep on expanding this. 5 plus 1 is 6. 10 plus 5 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6 and 1. You understood?
Yeah. Yeah.
So for smaller values, you can use, like, you know, I'm not saying in CBSE, but like MCQs are given. In MCQs, when they're not going to check your working, they only want your correct option, A, B, C, or D. In that case, what you can do when they're asking only for A, B, C, and D, only the options. In that case, best you can do is you can use Pascal's triangle for 6, power 6, because you writing 6 means 7 terms, right? A plus B to the power of 6 means there'll be 7 terms. 6 plus 1, 7 terms. So you developing that, you know, 6C0 and all the way up to 6C6. You'll have those 7 terms. It might be a little lengthy. For smaller values, go ahead and use the Pascal's triangle. Did you get it?
Yeah.
There's something else in this, if you have noticed, or if you have not noticed, that is called the hockey stick. Now, I'm not sure that you have seen, you understand what I mean by hockey stick. So it's really got to do with maths itself and how sports and maths are combined. Let's see.
Okay.
Somewhat. I'm not good at drawing, okay, but hockey stick looks something like this, isn't it? You add the values: 2 plus 1, 3, 3 plus 3, 6, 6 plus 4, 10. So when you turn, you get the sum of the values up to that point. You can, I mean, it's either way, clockwise or anti-clockwise, anyways. Like you have to start from 1. See, if you look at the other branch, let me start with let's say, just for your knowledge, okay, like if you want to fill it up quickly or something. So if I want 1 plus 2 plus 3, see, I can even do it this way. See, I get the same thing, isn't it? 3, 4, 5, 6. The sum of this, when you bend, you get the sum. And like, say, you can apply it here. So see, 10. Yeah, wherever you want, you start with the node that is 1 and go up to this. So there are many things that there's a lot of things in this only. Okay, so then you can even go on expanding this. But when we are out of reach, systems are programmed. Computers can be programmed to compute up to different values. But when we want to stop somewhere, like, you know, when we cannot go beyond, and Pascal's triangles doesn't help us, systems can program. We cannot work like a system, isn't it? See, for big numbers, we still use calculator. But I'm saying if you're going to use binomial theorem, then you can calculate anything up to A plus B to the power of, let's say, 18. If I give you also, you will have 19 terms. If you want, you can go ahead and write that. Okay. Again, then you'll have something called as a middle term. And then you'll have the 2 middle terms. When you have even number of terms, you have 2 middle terms. When you have an odd number of terms, you have 2 middle term, 1 middle term, isn't it?
Yeah.
When you have even numbers, like when we have 6. So 1, 2, 3, 4, 5, 6. Then these two become a middle term. When you have only 5, then you have only 1 middle term. So again, that matters, because when you have even, when they'll ask you to find the middle, we'll come across all that. Then what else? Yeah. As far as this demo class is concerned, I think this should be enough for you. I didn't want to load you too much on the very first session, because the reason is I thought you know something and you are taking it from there, but this is totally new to you. So binomial theorem has many more things. We'll find the middle term, then we'll find the term independent of x, and so there are so many things. So it's not now I've just shown you what is a and b. You can have 2x plus 5 to the power of 10. You get it? In the place of a, you have 2x. In the place of b, you have 5. Yeah. So you can expand this. I mean, the coefficients will be the same. Like just to show you, if I'm going to show you just one, the very first two terms, 10C0 NCR, okay, 2x to the power of 10, 5 is to the power of 0. Getting it? Same thing, nothing big. This is A, this is B. Plus 10C1, 2x to the power of, what will be the next term, Aishwarya? Power of?
9.
Very good. 5 power 1. See, progress, it progresses. And we would go all the way up to 10C10 when 2x to the power of 0. We write for you know, for the sake of completion, you write it so that I know, of course, I know at the end of the day that anything raised to power 0 is 1. But just to tell myself, I will write it here for the sake of completion. And 5 raised to power 10. At this step, I stop. How many terms will be in this expansion?
10? No.
10 plus 1. I told you, no? Whatever is the index plus 1 terms. Okay.
Yeah.
Okay. I'm just doing a quick, just check that you understood or not. Okay. And if I ask you, can you give me the 8th term? What will your answer be? I'm giving you the hint. TR plus 1 is NCR, A to the power of N minus R, B to the power of R. Of course, your A is 2x and B. Exactly. If I want the 8th term, what should I put my R as?
You have to put it as 7, right? Because
very good, very good, very good. Your R is 7. So it becomes what? N is of course 10 here, isn't it? 10C7. Got it? Yeah. The 8th term will be T7 plus 1. So R will become 7 for that. A is my 2x, isn't it? 2x to the power of 10. We'll not skip steps. I mean, I've seen students doing mentally and then let's write it down. What we can do mentally, we'll do, but it's always good to write it down and we can analyze better. We can't process much, isn't it? Like in real time. Okay. It's all right. Let's write it down. Maths is all about writing. And B is nothing but 5. R is, what is R here? It is 7. So that would be 10C7. And you can compute the value, isn't it? 10 factor. I mean, I'm just getting you into that 10 factorial by 7 factorial into 10 minus 7 is 3 factorial. That we can take it later. As of now, if it's big numbers, you can leave it at this 10C7, 2x to the power of 3, 5 to the power of 7. Yeah. And you can, of course, I mean, 2 cube. I mean, you can 5 power 7 is too much. Like you don't, it's not required. You can leave it at this. 2 cube we can do, right? 2 cube, 5 cube, up to cubes we can find. 2 cube is 8. 2 cube is 8. So, and 10C7 we can compute, isn't it? If it's very big, of course, you can leave, like example, there are situations where you have, like, you know, like say 98C, or something like 47 example, then you don't have to sit and calculate if it's going to go, you know, beyond your reach. Leave it at that. Here, this 10C7 can be calculated. And 5 power 7 is also quite big for us. So you can leave it at that. I mean, maybe this will be one of the options then. Okay.
Yeah.
So this is it. I just didn't want to, like, you know, put too many things because we went into too many different things. So this is all about binomial theorem, the essence of binomial theorem. So you have any questions for me, Aishwarya?
No, nothing.
Before we close. Okay. All right. I'm just closing on this session. I hope you got to learn something out of this.
Yeah.
Yeah. So wait, let me just, sir.
I think that's it, ma'am. That's it for the demo purpose. Anything you would like to ask Aishwarya to ma'am?
No, no.
Okay, I think that's it for the demo purpose. Yeah, thank you.
Okay, Aishwarya. Bye-bye. Hello, sir.
Yes, ma'am.
Yes, sir. So I can leave and in some while, you know, I think I was just watching the timer. I didn't want to go too further. I didn't start the exercise because it will go beyond.
That's okay, ma'am. That's okay for the demo purpose. 40 minutes is okay. 40 minutes is okay for demo.
Yeah, almost 40. Okay.
Yeah. So we will meet at 6 for the 9th one, right?
9th one, quadrilaterals. Yeah.
Yeah. Okay. Thank you, ma'am.
Okay, sir. Welcome.
Oh, yeah. Thank you.
Thank you.